This research paper introduces HexTiles, a novel hexagonal-tiling-based visual encoding design for multivariate geospatial data. The authors aim to address the challenges of visualizing and communicating insights from multivariate geospatial information data, which is limited by the rigid graph schema of geospatial maps. They highlight the need to simplify the process of interpreting interactions between multivariate geospatial data and to guide user attention to specific variables and interactions. The authors discuss the related work in multivariate geospatial visualization, including juxtaposition and superimposition approaches. They note that juxtaposition is the most common and flexible approach, but it can be ineffective at times due to the difficulty of contextualizing multiple views. Superimposition, on the other hand, displays multiple data channels in the same visualization instance, but it can lead to visual clutter and occlusion. The authors propose HexTiles as an extrinsic approach to combine multiple variables, leveraging semantic icons to encode data and provide a confidence encoding for each information channel. They calculate weighted variances of the variables in each HexTile to provide a confidence value for each tile, which can be used to interpret the variability of the data within the corresponding geospatial area. The design of HexTiles is motivated by the need to handle geospatial data of varying spatial discretizations and to ease the process of assessing interactions between variables across spatial regions. The authors enumerate 4 design considerations: handling geospatial data of varying spatial discretizations, assessing interactions between variables, enabling visualizations that prioritize certain information, and alleviating the Modifiable Areal Unit Problem, MAUP. The authors assess the efficacy of HexTiles via user study and a domain expert review with ecologists and hydrologists experienced in designing geospatial visualizations. They conclude that HexTiles is a promising approach for multivariate geospatial visualization, offering a novel solution to the challenges of visualizing and communicating insights from complex geospatial data. Here is a combined summary of pages 3 and 4 of the research paper. The paper discusses the concept of HexTiles, a visualization encoding design that encodes 3 geospatial variables at once, including confidence to address the Modifiable Areal Unit Problem, MAUP. HexTiles are based on hexagonal tessellations, which are smoother and allow for direct comparison between tiles. The design leverages pre-attentive processing of visual information and reduces reliance on color maps to encode data. The paper highlights the importance of visual abstraction in geospatial data visualization, including spatial binning and icons. Spatial binning is a widely used form of visual abstraction that aggregates data within polygonal regions. Icons are used to represent data, taking advantage of metaphors and reducing reliance on color maps. The use of icons can be expressive, making it easier to detect and compare data values. However, the paper also notes the trade-offs of employing semantic icons, including the loss of accuracy and the need for meaningful values to which regions with 0 icons can be mapped. The paper addresses the MAUP problem, which arises from the fact that the results of an analysis can be influenced by the shapes, sizes, and orientations of the polygons used to represent the data. The HexTiles design explicitly encodes confidence in each HexTile component to address MAUP. The confidence is calculated as a spatially weighted variance for each variable and is expressed via value-suppressing uncertainty palettes, VSUP, inner ring thickness, and opacity. The user can interpret the variability of the data within each HexTile region. The paper describes the implementation of HexTiles, which leverages the hierarchical hexagon-based spatial binning system H3 and the WebGL accelerated DEC.gl. The workflow of HexTiles involves 2 main steps: data aggregation and data encoding. Data aggregation combines the set of data within a hex region into one aggregate data point, and data encoding maps the set of aggregate data points to the set of 3 HexTile components. The paper provides guidelines for what data attributes are ideal for each HexTile characteristic and presents 2 case studies to evaluate HexTiles: the 2020 presidential election and demographics data in Texas, and outputs from CalSim3, the California Water Resources Simulation Model. Here is a combined summary of pages 5 and 6 of the research paper. The authors propose a novel visualization approach, HexTiles, to effectively communicate complex data relationships and uncertainty. HexTiles consist of a base color, inner ring, and semantic icon, which can be used to encode multiple variables and their uncertainty. The authors provide a guideline for choosing the mapping between data variables and HexTile components, ensuring that the design is flexible and adaptable to different use cases. The authors demonstrate the effectiveness of HexTiles through two use cases: 2020 presidential election data visualization in Texas and water distribution visualization from CalSim 3. In the election data visualization, HexTiles are used to encode % Democrat lead, % people of color, and population density. In the water distribution visualization, HexTiles are used to encode groundwater levels, difference of unmet water demand with respect to historical baselines, and scenario unmet water demand. The authors highlight the importance of variance encoding in HexTiles to alleviate the Modifiable Areal Unit Problem. By encoding uncertainty, HexTiles provide a more faithful representation of the data, allowing users to better understand the relationships between variables. The authors demonstrate the impact of variance encoding using the election data, showing how it enables users to identify diverse mix of areas with varying levels of Democrat-led and % people of color. The authors also present the results of a user study, which evaluated the efficacy of HexTiles in terms of accuracy and time to insight. The study involved 7 participants with varying levels of exposure to visualization, who were tasked with completing 2 tasks using HexTiles visualizations. The authors also conducted an expert review with 3 domain experts to gather feedback on the effectiveness of HexTiles in communicating complex data relationships. Overall, the authors demonstrate the potential of HexTiles to provide a more effective and flexible approach to data visualization, enabling users to better understand complex relationships and uncertainty in data. The study presents a novel visualization technique called HexTiles, which is designed to enhance the interpretation and interaction with multivariate data on maps. HexTiles uses a hexagonal layout with color and size encoding for each variable, providing a more efficient way of displaying complex datasets. This method is compared to the existing superimposition-based method, square glyphs, in terms of accuracy, time to insight, and user experience. In the quantitative analysis, the results show that HexTiles have a lower mean error rate and a lower variance in error rates compared to square glyphs for Task 1, indicating more consistent performance. Similarly, HexTiles exhibit lower variances in time to insight for Task 2, suggesting a more consistent mental load for interpretation. However, the study failed to reject the null hypothesis for all 4 hypotheses tested at a significance level of alpha equals 0.05, indicating no statistically significant differences between HexTiles and square glyphs in terms of error rates, time to insight, and success rates. Qualitative feedback from participants reveals that they found HexTiles easier to interpret than square glyphs due to the use of color over size. Participants noted that the size of squares in square glyphs was harder to interpret, especially when zoomed out, while HexTiles' color-based encoding made it simpler to compare and understand the variables. Moreover, participants reported HexTiles as less demanding and less frustrating to interpret, with higher performance and lower mental effort, as shown in the NASATLX survey results. The study also highlights the importance of variance encoding in HexTiles, which allows for a more nuanced understanding of the data distribution within each hexagonal region. This feature helps users gain additional insights that were not present without the encoding. Overall, the findings suggest that HexTiles may offer a more efficient and intuitive way to visualize and interact with multivariate data on maps, potentially improving user experience and reducing the mental load associated with data interpretation. In this study, the authors introduce HexTiles, a novel domain-agnostic superimposition-based visualization design for multivariate geospatial data. HexTiles utilizes semantic icons and a hexagonal grid to represent various data layers, enhancing the understanding of complex patterns and relationships in geospatial data. The authors conducted a user study and gathered feedback from domain experts, revealing that HexTiles facilitates better communication of multivariate data with the Modifiable Areal Unit Problem, MAUP, in mind, at a lower mental load compared to square glyphs. HexTile's design allows for the visualization of general patterns in data, with a noted preference for understanding multiple variables at once and identifying relationships between them. However, limitations include color interactions, visual complexity, and the potential for occlusion of underlying terrain. Future work includes exploring the usability of HexTile's height for data encoding, adaptive task-based hexagonal resolution, and incorporating temporal data. This section of the research paper provides a comprehensive overview of various visualization techniques for bivariate and multivariate geospatial data. It begins by discussing the importance of visualization in understanding complex datasets, highlighting how different visualization methods can be used to represent multiple variables on a map. The authors then delve into the concept of the Modifiable Areal Unit Problem, MAUP, which refers to the potential for different spatial scales and zoning systems to alter the results of spatial analysis. This issue is crucial in geospatial data visualization as it can significantly impact the interpretation of data. The paper also explores the use of color in visualizations, emphasizing its role in conveying information effectively. The authors cite studies that have shown that certain color combinations can lead to better comprehension of data, while others may confuse or mislead viewers. They emphasize the need for careful consideration when choosing color schemes for bivariate and multivariate visualizations. In addition to color, the authors discuss the role of spatial reference frames in enhancing the readability of maps. These frames provide context and help viewers understand the relationship between different locations on the map. Furthermore, they explore the idea of geovisualization, which involves using visual representations to explore, analyze, and present geospatial data. The paper also touches upon the importance of user cognition in map interpretation, referencing studies that have demonstrated differences in how people perceive and process visual information. It emphasizes the need for designers to consider these cognitive factors when creating visualizations. The authors also examine various tools and technologies used for creating interactive visualizations, such as Deck.gl, which allows for large-scale web-based visual analytics. They also mention the potential of new technologies like augmented reality to revolutionize the way we interact with and understand geospatial data. Finally, the paper concludes by highlighting the importance of understanding the limitations and assumptions of each visualization technique. It emphasizes the need for further research into the effectiveness of different visualization methods and their potential applications in various fields.